Hello, today we are going to be working on this expressions vocabulary. What we're going to be doing today is identifying different parts of the expression, which is really important because then we all have a common vocabulary, and when we start doing more advanced things with these expressions, we'll be on the same page and know what we're talking about. So to review the vocabulary to begin with, terms are a single number, a single variable, or the product of a number and a variable. For example, a single number would be like 5, a single variable would be like x, and the product of a number and a variable would be like 5x. These types of things are terms. They're usually separated by plus signs or minus signs. Coefficient is the number of times a variable is repeated. So in 7y, that is like saying that y is repeated 7 times. 7y is equivalent to adding up 7 y's. That is what 7y means. Coefficients can also be negative, such as negative 7y, and that would be like adding up a bunch of negative y's. So like that 7 times, you get the idea. A constant is a number with no variable attached. So that's going to be any of our whole numbers, 1/2, negative 0.75, anything like that. Whole numbers, these are all constants. They're constant, they don't change, there's no variable involved. And a variable is just the opposite of that. A variable is a letter or symbol that represents a value. So when you have something like x, it's not constant because sometimes x is equal to 2 and other times x is equal to 4. When we make the expression more complicated, such as 3x, we're saying that when x equals 2, 3 times 2 is 6. And when x equals 4, 3 times 4 is 12. So variables can equal different things, and that's why they vary, as opposed to a constant, which is just a plain old number that doesn't vary. 1/2 always is 1/2. Finally, like terms have the same variable and the same power. So 2x is like with 9x. Negative 7y is like with 12y. That's the same variable. And then they also have to have the same exponent on them. So 3a squared is like with 5a squared. But 3a and 5a don't go with 3a squared and 5a squared. They would go together. So these two would be like, these two would be like, these two would be like, and these two would be like. So let's get to work with these problems. So it says to find all of the listed parts of the expression. The first thing we're going to do anytime we have an expression is chunk it. We're kind of just practice for now, but it's going to be a really useful skill later when we need to combine like terms and add these expressions up. So you could use colors or shapes. First thing I'm going to do is put my first term in a rectangle, and I'm just picking rectangle as my first shape. Anything that's like with 64 is also going to go into a rectangle. 8 is like with 64. They're both constants, so they're both going to get the same shape. Notice how I put the plus sign in with the 8. In this problem, it's not so obvious why that helps, but it's really helpful once you have subtraction signs in there as well. So you always want to get whatever operation is before the number in the same shape. Now I'm going to do a blue circle for the next term, plus 9x. Plus 9x is like with 6x. So I'm going to get plus 6x in the same shape. Oh, and it looks like I forgot one more term with my rectangles. I left off the other constant. So no big deal, I'm just going to go back and get that. So now you could see that in the green rectangles, I have all my constants. Those are like terms. They could be added together. They don't have a variable. And in the blue circles, I have my other pair of like terms, my x's. For terms, the question when it asks for terms, I'm literally just going to list out each of the things in the shapes. So 64, 9x, I'm just listing them, that's why I have commas. 6x, 8, and negative 12. You don't have to write down the plus signs, but the 12 is negative, so I need negative 12. Coefficients would be anything that is attached to a variable. It's the number of times a variable is repeated. So it's going to be this 9 and this 6. So I'm going to list 9 and 6. Constants would be any numbers not attached to a variable. So that's going to be everything in my green boxes. 64, 8, and negative 12. And variables would be my x's. So here, that x and that x. Since it's the same variable, you only have to list it once, but you could list it twice if that's easier for you. So this would be the complete answer for number 1. Please pause the video and try to do the same thing with number 2. All right, hopefully you've paused the video and you've done the same, you've done problem 2. First thing I'm going to go through and do is my chunking. So I always just happen to start with my rectangle, but you could do whatever shape you want for your first one. So my first number is 3x squared. So anything with an x squared is going to go into rectangles. Notice how I got the plus sign in there. You always want to get the operation before the number in the chunk. Now I'm going to switch to circle, and I'm just picking blue randomly. My next term is plus 5x, so anything else with an x is going to go in this shape. Minus 2x. Really important to get the minus in there. And that's all for my x's. And I'm going to do a heart for my next one, 42. So I want any other constants in a heart, which would be 54. So now I have my chunking all done and I'm ready to start answering the questions. Terms would just be listing out each of the individual things that I have in my shapes. So 3x squared, 5x, 42, 54, negative 2x, and x squared. The fact that we have the negative sign in there with the 2x makes it really obvious to us that the term is negative 2x. Without the chunking, it's hard to see that it's negative. Once you have the chunking, though, it's super easy. Coefficients would be any numbers that are attached to a variable. It's how many times the variable is repeated. So 3 is going to be 1, 5 is going to be 1. This one's tricky. Negative 2 is going to be 1. And then every variable has a constant. So for this last one, we have to, every variable has a coefficient. So for this last one, we have to say how many times is the x squared repeated? It's repeated once. So the secret coefficient on the x squared is 1. So my coefficients are going to be 3, 5, negative 2, and 1. Anytime you have a variable, it has to have a coefficient along with it. Next, I'm going to do my constants. That's going to be my numbers in the green hearts, 42 and 54. My variables. In my red rectangles, I have x squared. That's a variable. And in my blue circles, I have x. That's the other variable. If you want to write them more than once to show that they're in the expression more than once, that's okay, but that's not required. All right, please pause the video and try number 3. All right, hopefully you've paused the video and you've tried this one. I'm going to go through it a little faster. 14 is going to go in my rectangle along with 25. Those are like terms. Those are my constants. 3x plus 3x is going to go in the same shape as plus 15x. And then I have one more, 9xy, and that's going to go in my last shape. For the terms, you're just going to list them all out. 14, 3x, 9xy, 15x, and 25. Coefficients are going to be this 3, this 9, and this 15. 3, 9, and 15, they're all positive. Constants are going to be my numbers in the rectangle, 14 and 25. The variable's kind of wacky here. We have x in the red circles, and then in the purple heart, xy is the other variable. When they're smashed together like that, they're a single variable. You don't break them apart. And that's where this video is going to start. It's going to stop for now. So there's the whole page. If you wanted to see the whole page together again, you're welcome to take a screenshot. Hope this made sense to you, and yeah, talk to you later.